So we actually stopped at PIC 18 CPU register. Just to have a very quick recap, we actually saw on data memory. What is the capacity of data memory? 4096. How many bits do you require to uniquely address 4096 locations? 12. Very good. Then we also saw on program memory. What's the capacity of program memory? It's 2 megabyte, and that is equivalent to 2,097,152 bytes. So how many bits do we require to assign unique address? 21 bits. So then we progress to PIC 18 CPU registers, and these CPU registers are actually part of the special function register which are in data memory. Do you recall this part? So it is from FD8 until FFF. So they are known as CPU registers. Now out of the CPU registers, we have seen these are the table of the CPU registers, and you can see from FD8 until FFF, and each one of them have a name, so it's not so clear here. That's okay. So we are going to see the first two, which is working register. WREG stands for working register, and then there is status register. So working register is involved in the execution of many instructions. So later on, after this, when we go into the subject matter of instruction categories, we will see how this working register is affiliated with most of the instructions, and you will understand the concept why we have working register later on. And then the second one is status register. This is maintained by who? The control unit, right? Control unit maintains the program counter and also the status register. So we shall see status register before we see on the working register. So this is status register. So what is the address of status register? FD8. So it is one location in the special function register which is located at data memory. Are you all following? So in one location, how many bits can we store? 8. So very good. And that is what projected here. This is one location. How many bits you have? 0, 1, 2, 3, 4, 5, 6, 7. Total of 8 bits at one location. You all following? Now, out of this 8 bit, this is status register. Status register only uses 5 bits. So you see bit number 7, 6 and 5, they are dash dash dash, which means not used. And you can see bit number 0 is C, bit number 1 is DC, bit number 2 is Z, bit number 3 is OV, and bit number 4 is N. So what does that stand? N is for negative, OV is overflow, Z is 0, DC is digit carry or digit borrow, and C is carry or borrow. So it uses this 5 flag or what you call as indicator to indicate whether is there overflow or no overflow. So that's why it's known as a status register. Remember what is the function of status register? Well, I did mention you're supposed to memorize, right? So when do you plan to do that? For test 1? Come, refer and tell. If you're not telling, when are you going to tell? Yes, indicate overflow, occurrence, all that, right? So we will do some example, but let us look at the description of each one of these bits. N is actually the negative bit. So if the flag, if it's 1, it means that the result is negative. If it's 0, the result is positive. OV means overflow. If there is an overflow, the OV bit will become 1. No means 0. Z is for 0 flag. If the answer is 0, then the Z flag will become 1, otherwise it will be 0. And then you have DC. DC is digit carry or borrow bit. If there is a digit carry, the bit will be 1. If there is no digit carry, it will be 0. And C, if there is a carry, it will be 1. If there is no carry, it will be 0. So we will try to do examples so that you can understand much more easier. Is that okay? So these are some of the favorite questions in test 1. They'll ask you to determine what is the condition of the status register. So here we have a simple addition. Determine the condition of the status register after the following operation. Hex 78 plus with hex 64. So we don't need to convert this into binary. You can actually straight away solve this using in hex. So how can we solve this? What is 8 plus 4? It's 12, which is C. So you write here C. 7 plus 1, 7 plus 6, that is 13. 13 is D. So you get the answer hex DC. Now the status register indicates the condition of the result. So when after you perform this addition, the result, based on the result, the status condition will be flagged accordingly. So how do we fill the answers? So let's do one by one. N. Is the answer negative? That's the first question. Is it negative? Positive or negative? Okay, there are two answers. There's positive, there's negative. Why positive? Why negative? One zero is? Yes. Oh, orange color. Okay, sure. Thank you. This one cannot. So coming back to the point, is it negative or positive? Okay, why is it negative? Yeah, because the most significant bit for D is 1. How you know? Convert into binary. If you convert to binary, what is D? What is DC? This is 1 1 0 1. C is 1 1 0 0. Do you see that the most significant bit is 1? So it is negative. On another note, we are dealing with 8-bit numbers, and 8-bit numbers falls within the range of hex 00 until hex 7F. With 8-bit, you can actually represent a value from hex 00 until hex FF, right? Do you agree? Don't simply agree, huh? Why you agree? Why you agree? Why with 8 bits it is from hex 00 to hex FF? If you have 8 bits, you will have 2 hex digit, right? 4, digit per one hex digit, so you have maximum 2. Is that okay? So if you notice, the range from hex 00 to 7F are all positive, 80 to FF is all negative. You see the last number, which is 7F. 7 is 0, 1, 1, 1. F is 1, 1, 1, 1. After that is 8. So 80 until FF, all the most significant bits are always starts with 1. The most significant bits are 1, and therefore they are all negative. So this is an easy way for you to actually identify. Is that okay? So here DC is of course more than 7F, so it is negative. If you forgot this, just convert into binary. You can just look at the most significant bit. Any question up to this point? So what is the value? It is 1. Next, any question before we go on the next one? Guys, I'm talking to you. Yes. You can say yes or no. You can also give binary answer. Overflow. Now, do we have overflow? Okay, how do we know whether we have overflow or not? So 78, is it positive or negative? It's positive number. 64? Positive. Positive plus positive is supposed to get? But you are getting? So there is an overflow. Is everyone clear? Any question up to this point? Next is 0 flag. Is the answer 0? Definitely no lah. You see, no. DC, but my D look like O, huh? Let me write back complete. Anyway, 0 means both has to be 0. The 8-bit answer result has to be 0. So because it's not 0, it will be, what will be the value of 0 flag? 0. Do we have digit carry? So what is digit carry? So if we look at the definition of digit carry, a carry out from the 4th low order bit of the result occurred. So what does it mean by the 4th low order bit? Okay, I'll just break down this 7 and 8. So 7 is 0, 1, 1, 1, 8 is 1, 0, 0, 0. Plus with 6 is 0, 1, 1, 0, 4 is 0, 1, 0, 0. This one is the 4th order of the low bit. So it says, is there a carry out from the 4th order? So do we have a carry out? Why this 4th order? Because remember that each 4 bits represents a number, 1 hex digit, right? So from the 4th low order bit, if there is a digit carry, that carry is actually known as digit carry. So which means when you add these 2 hex number, do you have a digit carry? You don't. If you do in binary also, you see there's no digit carry. So for example, let me just solve this. This is 0, 0, 1, 1. So there is no digit carry, you see. Then 1. Okay, here you have a carry, but this carry is not known as digit carry. Digit carry is only considered from the 4th low order. 1, 1. You also have a carry here, but a carry out, I would say, it's not a carry out to the next digit. But all these are not digit carry. So digit carry is only from the 4th low order, which is represented here, right? 8 plus 4, if you have a digit carry, then only you add to the next digit, right? Where does the next digit start from? From here, right? This is the next digit. Are you able to follow? So do we have digit carry? So what should be the value of DC? 0. So do we have carry? Now carry is a carry out from the most significant bit of the result occurred, which means here if you have a carry out from here, this is known as carry, which means when you add 6 plus 7, when you add 6 and 7, if you have a carry out, that is known as carry, which means you are getting a result more than 8 bits. Do we have a carry? So what should be the value of C? So this is how you determine the value of the status register. Is that okay? Let us try another example. We have hex 99 plus hex 67. So let us try to solve this first. 6 plus 7. Oh, sorry. 9 plus 7. 16. So what should I write here? 0. So in base 16, the maximum allowable digit that you can write is 15. If anything which is more than 15, what you do, you minus with the base number, and the number of times you minus the base number is what you carried out on top right. Same like how you perform in decimal. If you have 12, what do you do? Let's say 6 plus 6. You write 2 and put the 1 and the next digit right. In a sense, 12 has exceeded the base number by how much? By 2. How? Minus 10. Then you write the remainder there. Then the number of times that you minus 10 is what you will carry out to the next digit. So here is exceeded base number 16. The allowable digit is 15. So 16 minus 16, you get 0. Carry 1. Yes? 9 plus 7 is 16, right? 16 has actually exceeded the maximum allowable digit for hex, which is 15. So you need to minus with 16. Just like how, for example, if we have 6 plus, let's say you have like something like this in decimal, 16 plus 16, 6 plus 6 is 12. But you don't write 12 here, you write 2 and you put a 1 on top right. In essence, 12 has exceeded the allowable base number. So what you do actually, 12 minus 10, which is 2, then the number of times that you minus, you increase to the next digit. So the same principle applies here. Okay, just to make it more relevant, five plus 5. It's actually 10, but we are always used to writing 0 here and 1. The principle is the same thing. It's actually you get a value which is actually more than 9. So you always minus by the base number. The remainder you write and then you add the carry to the next digit. Because we are so used to decimal, so we always think that half of the number we write here, half of the number we write on top. The concept is when you add a particular number, when it's exceeded the allowable digit, you should minus with the base number. So that's what we are doing here. 16 has exceeded the maximum allowable digit for hex, so you need to minus 16. So get 0. How many times you might How many times you minus is the time that you add the carry to the next. You can also look at this on another perspective. 15 is the maximum allowable digit. Now it is actually 16, which is extra 1 from 0 in hex. Sounds more confusing now. We'll remain with this lah. Is it okay? So just remember this formula. Whenever you add a particular number, if it exceeds the maximum allowable digit for the particular number, you have to minus with the base number, and then you have a carry. Again the same thing here. We have 10 plus 6, 16 again. So again 0, and you have a carry, right? So you have a carry there. So based on this answer, let us determine the status register. Is the answer negative? Definitely the answer is not negative. Is it? Do we have overflow? This is 9 is negative. This is positive. And you get 0. This is correct. 0 is positive or negative? Yeah, 0 is always has been a debate. It's definitely not a negative number. So I just want to show one thing here. Negative plus with positive supposed to get what? Now this is a special unique case where you're actually getting 0. So of course there is no overflow here. You're getting 0. So it's not an overflow. Okay, I want to show you an interesting thing about this number. This is this hex 99 and 67. If you want to represent it in binary, 8, 4, 2, 1. So this is 99. So you know 9. This is 1, 0, 0. 1, 1, 0, 0, 1. 6 is 0, 1, 1, 0. 7 is 0, 1, 1, 1. I've just converted this 99 hex and 67 hex. Now can you find what is this value? This, you know, it is a negative number, right? If it's negative number, you look at the weightages of 0. Look at negative of the weightage of the zeros, right? 64 plus 32. How much is 64 plus 32? 96. 96 plus 4. La. Plus 2. Plus 1. So it's negative 103. Now this one is positive number, so you look at the weightages of ones. So 64 plus 32, 96 plus 4, 100 plus 2 plus 1. So this is actually positive. So now you know why you're getting 0. So this some of the tricks numbers can play. FII only. So is it 0? No, this is a sure definitive answer is 0. So this is 1. Do you have digit carry? Yes, we do. Then we have digit carry, right? This one. This is digit carry. So we have digit. Do we have carry? Yes, we do have carry. So 1. So this is the answer. Any question up to this point? Yes, Thiran. You don't understand the overflow. Okay, overflow when you get the wrong sign, right? In this case, one is negative, one is positive, but the answer you're getting is actually 0. So there is no sign, and it is not a wrong sign. When equal amount of positive adds up with an equal amount of negative, you get 0. So that is not a wrong signage, and so therefore that's why there is no overflow. So just to prove, that's why I showed you in this binary format in its decimal value, which is negative 103 plus with 103, so you get 0. So 0 is a unique thing, there is no sign for it. So therefore there is no wrong, there is no overflow here. Good.
Decimal under 53 changed to extra is also 99.
Come again?
Decimal under 53.
153.
Decimal.
Okay.
Change to extra means consider 99x.
You are doing calculator, is it? Calculator operates on 2's complement, but you cannot solve 2's complement using calculator. You will not get. What you're trying to do is you're converting the hex 99 into decimal, is it? And you're getting 153. So what calculator is doing is it is taking this value and converting it unsigned number. That's why you're getting 153. The same thing, this 1001, if it's signed, the value is negative 103. If it's unsigned, then 1 to 8 plus 16 plus 8 plus 1, and you will get the answer that you say 155. So whenever, just to prevent you all from getting confused, whenever you are doing a operation, arithmetic operation, the numbers are always signed numbers. Just for you to know, good that he asked. Some of you may have this question, oh yeah, when do we consider binary as a normal binary unsigned, or when do we consider as a sign? So whenever you're doing arithmetic operation, confirmed the numbers are all signed numbers. Good. This kind of question when you ask, you'll learn a lot more. Any other questions? Are you getting the answers for your questions? Do you get scolding for asking? I mean, do you get scolding for asking? I think you only get scolding the otherwise. 5% no? This tablet telling me. Okay, let us continue. The next example. So we have 90 plus hex 67. Is it the same? Oh, this is 90. So 0 plus 7? 7. 9 plus 6? 15, which is F8. So let's do one by one. Is it negative? Is it negative? The answer? Yes, it's negative. F is, if you, just in case if you have forgotten the range hex 007F is positive, hex 80 until FF is negative, if forgotten, it's okay. Just change it back to binary and you can see that the most significant bit is 1. Do you have overflow?
No.
So this is negative number. This is positive or negative? Positive. So negative plus positive supposed to get? Depends on the which number is larger. So which one is larger? This is where we all fall for the trick. Now don't think because 90 in hex is larger than 67 and therefore it is a larger negative number. That is not true. If both numbers are positive, then you can directly compare the numbers. You can see which one is larger. But remember why you cannot compare directly with negative? Because the way it is represented is different from positive. So if you want to look at this, anyway, what was the hint? If you add unlike sign, can you get overflow? Because I forgot and I'm asking you. I just give the hint. It's what, impossible to get overflow, is it? I don't know, I'm asking. Hey, you all didn't write the notes. If you add unlike sign, may you get overflow or is it impossible? Impossible to get overflow. But let us try to just be sure. The answer you are getting negative. So in this case it is 1001, 1001, 6 is 0110, 7 is 0111. Okay, if you write the weightage on top, of course I think in this example, yeah, I am following the earlier one. Thank you. In this example, still the negative number is larger if I am not mistaken. So here you will get 96. So this is quite a large number, right? You get negative 96, 410, yes, 112. And this one you get positive 96 plus 6 is the same. Sorry, 113, yeah. 96 plus 400, 103. So in this case, yes, the negative number is larger, but still, whatever I mentioned just now, don't take the number as it is. There will be some other examples where the number doesn't really reflect a larger negative number. So I'm not so sure whether is it in this example or not, but you need to check. So in this case it is true, you're supposed to get negative and you are getting negative, so therefore there is no overflow. So always perform a check. In this case, like I mentioned, coincidentally it is larger, but if some other numbers are there, not necessarily the negative number will be larger than the positive one, so you have to check. But since we can also use the hint as a guideline to check whether will there overflow or not. So since we are adding unlike sign, it is impossible, then we have also proved it here as well. So do we have 0? Is the answer 0? Do we have digit carry? No. Do we have carry? So this is the answer. So we have been doing addition all this. Any question up to this point? Any question up to this point? Okay, now let us see subtraction. We have been doing addition all this while. Let us do subtraction. That's the reason why we're doing subtraction. So take away 1 from 7, you get 6, then you get 2. So this is hex 26. So is the answer negative? No, it's not. Do we have overflow? So we have to check. This is positive. This is also positive. So positive minus positive, supposed to get, depends on which number is larger. But since both are positive, so you can straight away look at the number. So 37 is larger than hex 11. For positive we can do that. For negative you have to be a bit careful. Sometimes it doesn't always hold true. So in this case you don't have to convert. For positive you can straight away compare the numbers. So this is supposed to get positive and you are getting positive, so there is no overflow. So is it 0? No. Now here, because we are doing subtraction, it is no longer known as digit carry, it is known as digit borrow, and this is borrow. What does it mean by digit borrow? Do we borrow from the second digit, the upper byte digit? Do we borrow? Digit borrow means you're borrowing. So this is dB and this is P. If you remember, we did the sign extension, assume that we borrow, so that is known as borrow. So do we have digit borrow? So what should be the value of DC? Zero. It's 1. Why? Is because for borrow the polarity is reversed. Same. There's a reason why they do that. I'll explain why. So whenever you do subtraction, if there is no digit borrow, usually wherein there is no, we'll put 0, but this one is reversed. The polarity is reversed. So when there is no digit borrow, we write 1. Do we have borrow? No. So we should write 1 as well. The reason why the polarity is reversed is because, as I mentioned earlier, in reality all the subtractions are done addition. So this one, if you look at this, this is 37, which is 0 0 1 1 0 1 1 1, and we have the negative 11, right? We actually want to make it positive. So what we do with 11, we are going to make it negative. So the negative cancels out, becomes positive. So 1 1, I'm just going to do a side here. This is 1 1. We need to perform, we are going to do negation here, right? So negation is, first you do the first complement, which is toggling, and then you plus 1. So this is negative 11, negative hex 11 lah. That's what I'm trying to say. So you're going to add it here, 1 1 1 0 1 1 1 1. So it performs the addition. So you get the, sorry, 1 1 1. So do you see that you have a digit carry? 0 1 1 1 F1. So do you see that you have a carry? Oops, I wrote in that color. Did you notice that you have digit carry and you have a carry? So that is why the polarity is reversed, because in reality it performs addition, and when it performs addition the C and DC becomes 1. Is that okay? Yes.
Can we perform the first complement and then we do the addition, and then we leave the carry and carry as it is?
Oh yes, can. You can solve the same question like how I did just now. You will get the same status register answer.
So we don't rename it as digit borrow and borrow. We can digit carry and carry.
Yeah, in status register the name of the bit is always DC and C, but when we do subtraction we say as digit borrow, but in actuality, in reality it only performs addition, and therefore in the status register that's why it's only DC, it's not DC/DB, it's only DC and C, because it always performs addition. Any question up to this point? Okay, let's finish the last one up. And okay, so this one subtraction. So C minus E. So this is a smaller number, so we need to borrow, right? So you borrow, this guy becomes 4. How much are you borrowing? 16. So 16 plus C, C is 12. So you get 28. 28 minus E, how much is E? 14. So 28 minus 14, you get back 14, which is E. 4 minus 1, say 4 minus 3. So hex 1E. So again, let us try to do the answer. Is it negative? Is 1E negative? Oh, it's positive. Do we have overflow? So this is positive minus positive. So which one is a larger positive number here? The upper one. For positive you can directly compare. So by right it's supposed to get positive, and you are getting positive. So there is no overflow. Is it 0? No. Do we have digit borrow? Yes. So what should be the value? 0 is opposite. Do we have borrow? No. So 1. The same thing applies as well. If you perform 2 complement on the subtrahend and perform the status register, you get back the same answer. Any question up to this point?